So all cloud providers I know, they got rid of layer 2. So you don't have any native layer 2 constructs in any public cloud. Everything you see is fake.
What?
Hold on.
Slow down. What do you mean
Yeah.
it's fake? What do you mean it's fake? That means that my subnet side of the block is fake?
Absolutely.
Oh.
Yeah.
Good morning, good afternoon, good evening, wherever you are, ladies and gentlemen, and welcome to Tech Beats Unplugged, the podcast where we groove into the latest tech trends and vibe with the flow of cloud possibilities. I'm your host, 𝐒𝐿𝐴, aka Cloud Dude, and I'm pumped to be here with y'all. And strap in, people, because we got an awesome topic today, which is networking in the cloud. This is part uno. You thought migrating to the cloud would get rid of your routers and switches so you won't have to deal with any of the on-prem network chores? Wrong. But fear not, as we summon our expert guest and networking guru, Jose Moreno, all the way from Munich, Germany, working as Azure Principal Engineer at Microsoft to share his knowledge and shed some light on those dark and mysterious alleys of network in the universe of hyperscalers. Maestro, Jose, welcome and thank you again. Or shall I say, guten Tag or buenos dias?
Guten Tag, 𝐒𝐿𝐴. Thanks for having me, sure.
Oh, thank you. How you doing?
I'm doing awesome, my friend. Actually, these days I'm in Spain visiting my family. So if people hear Germany but notice that I don't have a German accent, that's the reason why, right? I've been born and raised in Spain, and I'm visiting the family over Christmas.
Nice. How's your German doing, by the way?
Yeah, it's a great place to live in. I live in Munich, as you said, and it's a fantastic city. Lots of green areas. You can do lots of sport outside. Even though this time of the year is a bit too cold, but it's a really nice place.
Sounds so cool, man. Okay, so I didn't want to spoil too much about your profile. I know you're a CCIE. That's all I care about. So you're welcome to introduce yourself and tell us a bit more about you.
Yeah, definitely. Thanks for the opportunity, first of all. So, I've been around 23 years in the industry.
Wow.
So I started in my home country in Spain, and then I moved pretty early to Germany. I started to work in computer networking. At the time, it was a bit of everything, including token rings. So I guess I'm showing my age here, and another prehistoric technologies there. Eventually, I decided to start on that certification journey with Cisco, which took me along the path of the CCNA, CCNP, CCIE, CCDE, etc. After that, I had the opportunity to move over to Cisco. I spent there a very interesting 10 years of my career.
Wow.
Where I had the opportunity of working with different technologies, including software-defined networking, Kubernetes, virtualization.
Nice.
And one thing took to the next. So 7 years ago, I moved over to Microsoft to get even deeper in this new networking or new generation of networking.
Mm-hmm.
I've been in Microsoft focusing on cloud networking for the last years, and my job is helping customers that are deploying applications in the cloud to solve their networking challenges. So to help them to overcome those difficulties you were talking about early in the podcast about not being able to get rid of your switches and routers.
Exactly, right on. That's the kind of cocktail we need for today's discussion. Cisco, Azure networking, cloud adoption, enterprise architecture, the perfect sauce. Okay, first, I would like to start with a simple question, which is, how did you enter IT and the networking world? Tell me about your first steps, the experiences, some milestones that got you where you are today.
Yeah, that's a great question, 𝐒𝐿𝐴, and it was a bit of luck involved. So when I finished my studies in Spain, I've always been into computers, right? Like I had one of those very old computers early on, right? It was an Amstrad. I will have that piece of hardware forever in my heart. But my studies took me a bit away from that. I studied telecommunication engineering in Spain, so a lot about antennas and radio frequency. And right after finishing those, I saw the opportunity to join both together, telecommunications with computers, in essence, computer networking. And I was offered a position in a company called Amadeus in the travel industry.
Amadeus, isn't that the application that would allow you to book flights?
Yes, exactly. Now they've diversified a lot. At the time, it was mostly booking.
Okay.
And I had the opportunity to look at different technologies they had over there. But, with networking, it was like love at first sight. It was extremely interesting to me, the challenge that you have with a distributed system, like a complex network.
Wow.
I had the chance to get in contact with very different technologies like MPLS, like wireless LAN, like a data center network, like a campus network.
Wow.
And there was no way back there. So, I decided to start getting deeper and deeper into the rabbit hole, and that took me to where I'm today.
Wow. Amazing, man. So with your 10 years spent at Cisco, I want to reflect on the changes in networking from the Cisco, Juniper golden years to the cloud native era. What has really changed for network admins that requires them to adapt or flip, in your opinion?
Yeah.
It must be more than tools, right?
That's a very interesting question. And I'm going to answer that partially because when we say networking, there are many networkings, right? In my career, I've mostly focused on data center networks. So I'm not too experienced in campus networks or in wide area networks. As I was saying earlier, I've done a bit of MPLS, I've done a bit of Wi-Fi and network access control, but my core experience is in data center networks.
Gotcha.
So I followed the evolution there in first person, so to say. And in that particular area, in data center networking, there's a lot going on. And there has been a lot going on in the last, say, 10 to 15 years.
Yeah.
So at the beginning, right, like as you were saying, early on, it was mostly about knowing your layer 2 in order to build a resilient and performing data center network. But early enough, virtualization came.
Yeah.
And while when in the early days of virtualization, it was just a virtual switch with very limited features. So the intelligence still was in the network. More and more functionality started wandering towards the hypervisor as an option, right? It wasn't compulsory. And fast forward a couple of years, and then you have overlays, you have NSX-V, NSX-T from VMware. Then from a parallel angle, Kubernetes came with a very interesting concept, at least from a networking perspective.
Yeah.
With this massive adoption for containers in the developing community. And a few years later, cloud comes into the picture, right? So you have the perfect storm where the network admin is pulled in different directions from these very different forces, right? And I think that's the main change that has happened to the networking administrators. They don't have the luxury of just focusing on knowing the CLI command by heart of their preferred networking vendor, but they have to play nice with these new kids in the block, like Kubernetes, like NS6, like cloud, because hey, they're here to stay. So if you limit yourself to just the physical part of your network, you are limiting yourself to a very well, maybe not small, but definitely not the whole of it.
True. Okay, surfing on the same perspective, what do you think is the core difference in terms of vision between the on-prem and physical realm, BS, cloud, and software-defined network paradigm? Everything didn't just start with the cloud, right? Virtualization brought a lot of breakthroughs when we started seeing VMware NS6, vSANs for storage, Cisco SDNs, vEdge, and Nexus. Cisco was even a major player in the SD-WAN space. What's the big differentiation in the cloud?
Yeah, another great question, 𝐒₝. So I wouldn't necessarily equate cloud with SDN, right?
Oh.
So I will answer the question from the angle of what's the main difference between on-prem, whatever it's a physical network or SDN,
Got it.
and cloud. Because at the end of the day, I don't think that on-prem physical network and on-prem SDN or SD-WAN, right, whatever the software-defined might mean, because that's another interesting discussion, is that different. However, when you look at cloud networking, the main difference is that you don't have all of the features at your disposal as a network administrator. The cloud provider is going to give you an API that is going to configure a very small subset of features that you know from your on-prem networking tools. Because the cloud provider will have designed their underlying network and their API, the networking API that they offer you, with one goal in mind, which is scale. Scale with all capitals, right? It's like a scale where very few on-prem network administrators have ever known of.
I see.
Like not hundreds, not thousands, but tens of thousands or hundreds of thousands of devices.
Wow.
So, and that's what I see most networking administrators sometimes struggling. Like, hey, for example, I have policy-based routing in my network since ages. I have multicast in my network since ages. How come you guys don't have it in the cloud? You are Amazon, you are Google, you are Microsoft. You should have these things, right? They are not that new. Why don't you have them? And the reason is because, hey, some features do not make sense from a scale perspective. So when you are coming to cloud, you shouldn't think, or you shouldn't rely on the premise that all those fancy features are going to exist up there, right? And I've seen organizations struggling with applications that rely on fancy networking configurations, such as exotic load balancing protocols, or multicast, or I had recently a customer that had implemented a very interesting concept of IP mobility with proxy ARP. All that is probably, most likely, not going to work in the cloud. And at the end of the day, you have to make ends meet with whatever features the cloud provider is giving you, which is a completely different mindset of on-prem, where you ask a feature to your vendor and a couple of months later you have it if you are large enough an organization.
And with decades of development too.
Yeah, and if you look at the functionality of a physical switch or an overlay network, and you compare it to the functionality of the cloud network of your public cloud provider of choice, it's hilarious, right? It's the cloud network seems ridiculous in comparison.
Wow.
And
it's a fraction.
Yeah, and the main difference, what many customers don't realize, is the massive scale at which these cloud networks operate. So I think that's, from a network administrator, I think that's the main difference. In public cloud, you have a much more reduced functionality, which is restricted to the APIs that the cloud provider give you to configure the network, and you have to adapt to it. There are some maximums, some limits, right? And those limits, when we talk about infinite scale, and then you compare to the limits of IPSEC tunnels, of IP addresses you can have in a VPC or in a VNet. sometimes you wonder as a user, like, hey, didn't we talk about almost infinite scale? And these guys are giving me like a ridiculous limit for my needs.
Right.
So, and of course, you can't forget that next to you there are other hundreds or thousands of customers sharing the same limits, right?
True.
And if you add all of those limits, then the resulting number is pretty impressive.
Exactly.
But hey, you don't care about the other customers. You only care about the requirements coming from your business.
Of course.
And you have to satisfy those with that limited scale, that limited functionality that the cloud provider gives you. So I think that's the main difference I see in the philosophy in which you need to approach network designs in cloud and in on-prem.
Got it. Thank you for reminding that SDN doesn't mean cloud necessarily, and there is a trade-off for everything. There's a cost to everything, including scale. So
there's no free lunch.
Oh no, there isn't, especially in the cloud. All right, you've probably seen some of the zillion memes about IPv6 Doom Day everywhere, which has yet to happen. But can we seriously address IPv6 status? Why are we so stuck? And things like dual stack network where all the nodes are both IPv4 and v6 enabled, still a good option to get IPv6 in the house?
Yeah. The IPv6 is a bit of a philosophical discussion, right? So we've been talking about IPv6 for 30 years now. I think it started in the 93 or 94. It's where it was ratified as standard.
Yeah.
And the limited amount of IP addresses was only one of the reasons why IPv6 was invented. The other reason was to fix some inherent unnecessary complexity in the way that IPv4 works today, where you need a layer 2 protocol running below, even if it's not really required. If you really think about it, you have some add-on protocols that connect this layer 2 with this layer 3, such as ARP, reverse ARP, like DHCP, which might not be required if you could design things a bit more elegantly, right? So these people came together and designed IPv6 as a protocol, as an elegant protocol from a clean slate. The problem is, guess what? This is everything but a clean slate, right? So it's not like you can switch off IPv4 and suddenly migrate everybody to your new protocol. As long as we have these people running IPv4, we will still need MAC addresses. We will still need ARP. We will still need DHCP and all these kind of things. Even, for example, if you think about it, we wouldn't need them in the cloud, right? In most clouds, we don't need layer 2, but we still keep layer 2 so that applications believe that they have a layer 2. The OS stack sends an ARP request to get the MAC address of their default gateway, and we give them the MAC address even if we don't need it for anything, and nor does the SDN in Google or AWS need that.
Wow.
So that leaves us at a point where, hey, IPv6 is very elegant, but that elegance comes at a cost because you need to modify applications to deal with it. So then the first thing that happens is, right, we give up on the dream of having a clean protocol, which will simplify things. And actually what we have is mostly dual stack designs, which actually make things more complex. Because on one side you have the IPv4 stack with DHCP, with ARP, with everything, and then you have the IPv6 world. Yes, more elegant. Yes, with more addressing space. But as you were saying, guess what? That doomsday that people have been preaching since 30 years hasn't arrived yet, right? IoT is here, right? Probably is going to get even the numbers are going to get even more impressive as years go by. But still, that's working okay. You have some service providers, some internet service providers giving IPv6 addresses to their users. Like, for example, in my my DSL provider in Germany, the default is IPv6.
Really?
And if you want a dual stack IP, you have to pay €1 more.
Interesting.
So yeah, it's €1, so I'm paying that. I have dual stack so that I can access both applications whether they are exposing IPv4 or IPv6 without any NAT penalty. Because fun fact, if you access an IPv6 app from an IPv4 IP or the other way around, you go through pretty intensive NATing and inspections and all sort of things that delay your that introduce latency, right? And if you are into gaming, it's a matter of life or death, right? that extra milliseconds of latency.
Of course.
So that doomsday hasn't come yet. People are finding more and more tricks to overcome those limits. And guess what? Even if you introduce a couple of address translations in IPv4, it's still more performant than going from IPv4 to IPv6.
Man.
So all that is delaying the migration to IPv6. So let me recap, because I'm giving you a long answer.
Sure.
The promise of simplicity of IPv6 hasn't actually fulfilled. It's actually the opposite. Then the scarcity of IPv4 has been addressed by other means.
Gotcha.
So I think we're here. We are going to see the coexistence of both internets, as Avery Penandron calls them. I don't know if you've read the blog posts of Avery. He works in Tailscale, or he founded Tailscale. He has some very interesting blogs about IPv6. I can only recommend to read those.
Nice.
They're highly informational, highly entertaining.
We'll put it in the show notes.
He calls this thing the two internets, because that's what we have now. We have an internet which is IPv6, a different internet which is IPv4. They are somehow interconnected together, and we will live in the coexistence of these two internets for a long time.
Damn, yeah, that's tough.
Yeah, that's my maybe not so optimistic take on this, but maybe I'm showing my age here.
Well, at least you're not delusional, so I'll give you that. All right, this one is bringing me some nostalgia. I remember prepping for CCNA back in 2008. And the cool thing then was the slick simulation tooling like Packet Tracer, NetSim, which helped me a lot. I wonder, what's the cloud equivalent for those tools today for the new generation of network students? Affordable, of course.
Yeah. My first answer would have been, hey, in public cloud, you don't need those. Because you can instantiate as many VPCs, VNets, as many SD-WAN appliances, virtual firewalls as you need, right? So imagine if you have your infrastructure as code and you want to test it, or you want to instantiate a networking environment in cloud just to try it out, you just do that.
You bet.
You just create a virtual network, you just deploy whatever networking appliances you want to deploy there. You create a couple of fake workloads. You can even simulate VPN tunnels I typically use either Linux boxes, Linux virtual machines with StrongSwan and Bird for BGP, or even some cloud routers that do not require any license to simulate IPSEC branches. And then you do your testing. You do your learning, or you do your lab configuration. So that's typically what I do. I was telling you earlier on that I work helping customers to solve their networking challenges in Azure, and that's what I mostly do. When I encounter a customer that has an interesting challenge, I simulate it in my own Azure subscription, trying to recreate what they have. And so far, all is going great, except one little bit, which is the physical or the dedicated interconnection to on-premises, what in Azure we call express route.
The hybrid link?
Exactly, what AWS calls direct connect or fast connect in Oracle, or the layer 2 interconnect in Google, right? So those are tougher to simulate, and those are typically the ones creating the more interesting challenges. So that's hard because it's not easy. I haven't found a perfect solution to simulate that properly. You can do certain things, like for example, there are some providers such as Megaport
Right.
who give you virtual routers in their co-location facilities. So with that, you can almost create an on-prem environment as you need.
Gotcha.
To simulate on-premises, what I often do is I create something in a different cloud, so that I'm sure that there's not going to be any interference between my Azure infrastructure and what I have in my quote-unquote on-prem, which spoiler alert, I normally use Google Cloud for that.
Okay.
And there I normally have some of these appliances I was telling you earlier on, like a Linux, like an Ubuntu machine or a cloud, a CSR, right? A Cisco router, even if now it's called in a different way. I think now it's called the Catalyst 8000D. Just to inject any number of prefixes I want to inject from on-prem to cloud and see if I can break things or if I can simulate the problem that the customer is having in the cloud. So going back to your question, apologies for digressing. No specific tool set, but I'm just using the native functionality of cloud in order to do that. Recently, I was talking to some colleagues that are managing the network in Microsoft for our developers. And they are doing exactly that. They are deploying everything by code. What they do is they deploy the infrastructure as code configurations to a separate subscription, non-production. They verify that it deploys properly, that it behaves as it should. And once that's done, they delete all those networking constructs and they deploy to production. So, hey, it's doable.
Interesting. Got it. And you already told me about those sandboxes where you can just spin those Cisco CSR images without having to pay any license, which is super practical, I guess.
Yeah. The CSR, I love that box, man, because it comes with all functionality. It's just limited on bandwidth and performance, which I don't need for functional tests. So if you know your iOS or your iOS XR, maybe I should say, then that's a fantastic box to use as network virtual appliance in the cloud, because you don't have to learn much. In my blogs, I tend to use Ubuntu's because I don't want to favor any specific vendor when I'm publishing anything. But yeah, if you look at my LinkedIn page, I have a strong Cisco background, so sometimes I use that one to kickstart my tests.
Got it. And the beauty of it is that you can also use infrastructure as code to tear down whatever you deployed in seconds, which is cool.
Oh, absolutely. Yeah, there are many ways in which you can deploy programmatically. I tend to favor the Azure CLI. It's not a declarative approach as Terraform would be, but for me, it's exactly the sweet spot I need, because I can use this to deploy the router and then send some commands over SSH and configuring the router. So I can create a fully fledged environment in a couple of minutes without very little human interaction. So I leave the stuff running. And then for whatever time it takes, I go back and then I have my environment to test whatever I need to test.
Nice. Okay, our audience is pretty eclectic, which is why I'll ask you these basic questions.
Okay.
What the hell is BGP and OSPF? And how is it different in the cloud? Is dynamic routing always cooler than static routing?
Okay. Yeah, absolutely. So... And now that you asked me that question, I realized that I might have been throwing acronyms at you without actually checking that everybody understands them or explaining them. So
no, it's cool.
I will try to be more considerate with this one. So yeah, OSPF and BGP are two examples of routing protocols, as you say, a way of dynamically exchanging routes between systems. So if I can reach certain networks, I can inform you that, hey, if you want something, if you want to communicate with those networks, send the stuff to me because I can reach them, right? OSPF is a member of the protocols known as IGP, Interior Gateway Protocols. Interior means that you typically configure OSPF between routers that you own. BGP, on the other hand, belongs to a different routing protocol family, which is called Exterior Gateway Protocol, EGP. And you know where this is going, right? Exterior Gateway Protocols you configure between routers that belong to different people. Typically, one, of course, belongs to you, but the other one will belong to somebody else. And as such, these exterior gateway protocols or BGP is the only the most prevalent member of this EGP family of protocols.
Okay.
As such, since you are interconnecting to each other routers that belong to different people, these protocols are cut with a different type of features, mostly targeting security, targeting the fact that you don't necessarily trust your counterpart because it belongs to a different organization. And BGP is actually the router on which internet is built upon, right? When one organization talks to another organization, when I say talk, I should probably say exchanges routes with a different organization, they always use BGP, Border Gateway Protocol.
Yeah, but so border means different routers at the edge of distinct networks. That's why we call them autonomous systems, right?
Exactly. So your organization, exactly, you deploy them at the border of your network. That's why it's called like Border Gateway Protocol. And your organization will be defined in the protocol as an autonomous system, because it's a network, right? And you will connect to other networks, and every network is its own autonomous system, and each autonomous system is identified by a number, this infamous autonomous system number in BGP, which appears so prominently everywhere. So, long explanation, but the fact is that if you think about it, when you configure, say, a VPN gateway in Azure or an ExpressRoute gateway in Azure, as we were saying earlier, Microsoft is going to give you some APIs to configure stuff, and yet you don't have full control on what those things are going to advertise or not advertise. So even if you have some control over them, over those APIs, these things actually belong to Microsoft, not to you. So you don't want to use an interior gateway protocol as OSPF to talk to those things. You want to use a border. You want to use BGP, right, to talk to those, because BGP will give you much more protection against bad things happening, and it goes both ways, right? It will protect Azure against things happening on-prem, and it will protect on-prem from things happening in Azure. So yeah, that's why you don't see OSPF in the cloud. You only see BGP, because it's the protocol that makes more sense for this kind of adjacencies of relationships between devices that are managed by different organizations.
Makes sense.
Yeah, you made as well the point of BGP versus static routing. I see that quite a lot, right? Not every organization out there is familiar with BGP. And I see a good number of network administrators being intimidated by BGP, and hence they go to static routing.
I see.
And yet BGP and any dynamic routing protocol is in essence dynamic. So maybe it's my enterprise network administrator voice speaking now, but whenever you can do dynamic routing, I always prefer it to, well, not always is a big word in IT, right? Almost always prefer it to static routing, because that's going to give me much more flexibility when I want to control how the network converges. When this Azure region fails and I want everything to converge to a different Azure region, or when my primary data center fails and I want traffic to move to the secondary data center. With a dynamic routing protocol, I can control that in a much more granular way and more in a much more automatic way than if I'm using static routing.
Gotcha.
So all in all, my recommendation to network administrators is to use dynamic protocols when they can, whether that's on-prem or in the cloud. Nothing changes.
Yeah.
And in the cloud, you need to go for BGP because it's the most appropriate protocol for exchanging routes with a device which is not fully controlled by you.
Interesting. So much depth.
We are getting geeky now.
I know, right? Well, speaking of which, you talk about outages, and I have one in mind, maybe two. So the first one was what happens when systems or routers advertise routes they don't own.
Oh, yeah.
Bad things can happen, I guess.
Yes, very bad things can happen, right? And I remember years ago, there was an incident where a network, I think it was somewhere in Africa, was advertising a chunk of routes that belonged to Google. So they were sucking a lot of traffic that they couldn't possibly absorb and reroute properly. So that was massive. So yeah, it's one of the biggest problems in the internet because in the early days, this was mostly based on gentleman agreement that everybody would advertise routes that belong to them or only manipulate routes that belong to them.
I see.
We've seen incidents of this type over and over again. So the BGP protocol has introduced some extensions to it that include authentication and authorization so that routes can be authenticated, right? And before you're allowed to advertise a certain route, there's a way of verifying that this route actually belongs to you.
Interesting.
However, these extensions to BGP are not implemented everywhere. It's more and more, right? So if you look into internet providers and big internet exchange nodes over the internet, these extensions of BGP that provide this authentication and authorization are more and more prevalent these days. They are not everywhere, but suffice to say that the internet is now a much safer place than it used to be, at least from a routing perspective. I'm not going to talk about other realms.
Gotcha. Totally. The second outage was one that happened last summer here in Canada. The company is called Rogers. It's a telco company. It was all over the news, and apparently there was a removal of a routing filter in their core network, which led to flooding of some of their network routing equipment with gigantic route tables. And that stopped their downstream routers from processing traffic in the whole country. ISP, mobile, debit card, and national chaos. I kid you not. Anyway, I'll share the link in the show note, but on top of it, they seem to have no true out-of-band management network, which would have saved the day, but instead they had to physically go to the data center to fix it. That tells a lot about knowing what to change and when to change it, right?
Yeah. Or when doing manual changes, right? Even if you know what you're doing, everything which is manual is subject to the human factor.
Definitely.
And I've seen enough of that. Yeah.
Good stuff. That one was a classic. Thank you. Now, let's talk shortcomings. I've gathered some interesting takes by some tech peers online regarding the cloud-native network layer. For example, some say that CSPs present familiar on-prem contracts like VPC, VNets, subnets in the cloud, but that's not really subnet in the physical underlay. I'll share the link in the show note, but let me elaborate a bit. Okay, an example was brought by Phil CTO from HashiCorp about GCP, where he pointed that a host-to-host routing isn't working like in a traditional networking VLAN on subnets. Because, quote, they're not real subnets, it's just a contiguous block, and there is no broadcast domain. Moreover, every host is its own standalone data domain. How come? Well, for example, in a /24 in reality, each IP is a /32 with its own broadcast form. That would mean that in that /24 subnet, two IP addresses within that range shouldn't be able to talk to each other because there is no ARP. unless there's some sort of underlying firewall rule that allows them to talk to each other. I know you can't answer for GCP, but how does the networking underlay work in Azure, for example? Are these exposed constructs like VNets and subnets legit constructs, as in a traditional VLAN, or there's some wrapping going on?
No, those subnets and VNets are not traditional by any stretch. So if you remember when I was telling about the problems that IPv6 tried to solve, one of them was these layer 2 broadcast domains and layer 2 constructs, which are not required, and more importantly, they don't scale. The layer 2 broadcast domains are one of the main reasons why that provoke outages in data centers. I've known some data centers where the number one application measured in bandwidth was ARP, which is not something that a massive cloud provider can live with. Right? So all cloud providers I know, they got rid of layer 2. So you don't have any native layer 2 constructs in any public cloud. Everything you see is fake.
What?
What do I mean with
slow down? What do you mean it's fake? What do you mean it's fake? That means that my subnet cider block is fake?
Absolutely.
Oh.
Yeah, it's not fake. It exists somewhere, right? And for example, if you configure a VNet with a /24, that /24 is what's going to be advertised to on-premises. But it doesn't mean that the /24 is a broadcast domain. Or if you configure a subnet with a /26 inside of that's not a broadcast domain either. You don't have gratuitous ARP. And the way sometimes I explain it is that if you think about SDN in the way of a network with a centralized control plane, that's exactly what every cloud is doing. So there's a centralized controller that knows exactly where every IP address is living.
Okay.
If you have that, I'm going to make a conceptual jump here. Please bear with me. If you have that, if you have this controller that knows where every IP is, you don't need MAC addresses.
Oh.
You don't need layer 2 at all. Because the only purpose of layer 2 is having unique MAC addresses that allow switches, layer 2 switches, to identify where everything is.
I see.
If you have that controller that takes that function, that knows where everything is, you don't need layer 2 at all. And if you can build a network without layer 2, your scale will massively grow. Because you won't have layer 2 impairing or reducing your scale with all those broadcast storms, all those ARP consuming bandwidth, etc., etc. So that's what all hyperscalers do to increase scale, to get rid of layer 2.
Gotcha.
And that brings some interesting challenges when you try to replicate layer 2 constructs from on-prem into public cloud.
Crazy, man. But in that case, why would we want multi-VPCs constructs then? Why do I need any subnet planning then? Why do I need IPAM or DHCP, DNS?
That
they didn't want to mess with the network admins, that's why? They kept the old school constructs?
In a way, right? They don't want to mess with operating systems. So the operating systems, they are used to layer 2 and layer 3. So they will come up to life. A virtual machine will come up to life, and the interface will have a certain MAC address, and then it will make a DHCP request to get its IP address. So we can give you an IP address. It could do another type of protocol to get the IP address, right? And it could come up without any MAC address, but today's operating systems don't do that. So most hyperscalers, they just respect the way in which networks behave from the operating system perspective. Another interesting consideration is the point you were making, like not only be considerate to operating systems, but being considerate to admins. And that's what I think is going to change in the future, because when you compare a hyperscaler cloud in Google, in AWS, in Azure, with something that hasn't been built for networking admins, such as Kubernetes, the public clouds, they still have route tables, they still have ACLs, like access control lists. They still have subnets, they still have VNets.
Yeah.
And now you look at Kubernetes, they don't have any of that.
Sure.
And still everything works beautifully.
Exactly.
You could add some of that on top, right? That if you need ACLs, if you need access control lists, you can add Kubernetes network policies. But per default, there's nothing of that. And that's incredibly appealing for developers, because they don't have to take care of anything of that. And actually, things just work, right? So yeah, I think that's where the cloud networking standards should start moving. They should be, because that trying to be nice to the network admin and creating subnets which are actually not subnets and the like has at the beginning it looks natural to a network admin, but it's deceiving, or it can be deceiving, right? And I would rather something more modern, like, hey, you don't have subnets anymore, something like Kubernetes, right? You do
like identity-based.
Identity-based is a very good approach, right? Or maybe something more rudimentary, like label-based, like Kubernetes does, right?
Yeah.
When you configure your load balancer, your backend is going to be anything that has this label. Or when you configure your ACLs, allow traffic to or from VMs with these labels. But today we still keep using these freaking IPs, right? And CIDRs. And I think that's bringing unnecessary friction to configuring flexible networks today. So if you ask me, that's the next barrier that cloud networking should break, like letting the shackles fall of traditional networking and adopt some more modern principle.
Yeah. All right. Got you. So it'll be up to the network admins in the future to learn wherever they have learned.
Yeah, true.
All right. My next question is around another classic networking construct, namely WAN versus SD-WAN. Could you start with explaining what they are and also their differences? And why would we even use SD-WAN in the cloud in the first place?
Yeah, sure. Big disclaimer, I'm not an expert on either, right? But I'll do my best.
Okay.
One wide area network, of course, is the network that you have connecting locations that are very far away, like hundreds of miles away from each other. And that has been traditionally done using private lines supplied by network providers. And people paid a lot for those lines, and the benefit was using some private connectivity between their different locations. Of course, using the internet to do that kind of communication for corporate traffic between headquarters or headquarters and branches was possible, but the internet was associated to poor performance.
True.
So around 10 years ago, with the whole software-defined movement, there were some folks who devised some very smart mechanisms to compensate for the inherent lack of reliability or guaranteed performance of the internet. So the problem in the internet is not necessarily latency, but maybe jitter, the change in latency. Sometimes you send a packet and it's super fast. Sometimes you send just a packet, another packet just 5 seconds later, and it's not that super fast anymore. So some applications are not able to live with that. And some folks design these algorithms where they could smooth out those spikes in latency from the internet, or even iron out packet loss from connections going over the internet. So their paradigm or their business proposition was, hey, you can get rid of those costly private connections that are for which you are paying lots of coin every month and just take our software technology, move those connections to encapsulated tunnels going over the public internet. And that's going to save you a lot of money. If you will, I have once I heard the expression that software-defined WAN is just a glorified VPN. It's a bit of an exaggeration, but there's a bit of truth as well, right? It's a tunnel over the public internet. That's a bit of truth. The exaggeration is that it does much more than only encrypting, which is it provides the necessary quality of service so that it's comparable to a private line, and hence it's able to, for the first time, to replace those expensive dedicated connections with interconnect data centers. Does that make sense, 𝐏𝐨𝐝?
Yes, it does. So the SD-WAN is just a tunnel through the internet that does all what regular WANs offer, but without having to pay for the expensive private links, apparently. Yeah. And we shouldn't confuse the SD-WAN and VPN, because SD-WAN, as I understand it, does way more than IPSEC with all those nitro performance boosters that improve traffic quality. Am I right?
Yeah, VPN cannot be considered to be software-defined WAN, even if it shares the same overall principle of sending traffic over tunnels riding on the public internet.
Gotcha. Well, it's way more clear for me now that you explained, because I'm sure a lot of us in the audience were struggling with these concepts, so thanks a lot for that. All right, I'd like some insight on a very critical networking design choice. So far, we've seen the emergence of two design pillars out there, the holy Hub&Spoke and the virtual WAN. Which one is or should be the favorite in your opinion? If the answer is it depends, then please explain.
Oh, that's a very loaded question. Right. Yeah. Let me give you an intro for the benefit of the people listening to this. So, you have in Azure the concept of virtual network or VNet, which is comparable to VPC in other clouds. And in those VPCs you would deploy, or those VNets you would deploy your VPN gateways, your SD-WAN appliances, as we were saying, your firewalls, etc. You could have many VNets though, because you normally have different VNets for different workloads. So you would have applications 1, 2, and 3. So that means you would have VNets 1, 2, and 3.
Yeah.
That would mean, in principle, that you would have to have 3 different firewalls, 3 different SD-WAN appliances, one in each of those 3 VNets, each for each application, right? But that would be horrendously expensive. So what we came up with years ago was a pattern that we call Hub&Spoke, where you would deploy your networking services on a central VNet, the hub, and then the workloads, your applications, would be in different VNets, connected or peered to that central networking VNet, where your networking services would run. That's a Hub&Spoke pattern. That is not always simple to set up, especially if you're using a lot of third-party appliances.
Yeah.
Some years ago, we came up with the concept of a managed hub VNet. The managed concept in cloud, I like to compare it with whether you are cooking at home and eating your dinner at your own dining room, or whether you prefer going out to a restaurant. You will have somebody else cooking your dinner for you, and somebody else bringing that pre-cooked dinner to your table, right? So you don't have to do absolutely anything. It'll be much easier. It might be more expensive. It will probably be more expensive. And you might lose some flexibility because, hey, if you cook at home, you can cook whatever you want.
Yeah.
You buy the ingredients, you cook with more salt, with less salt, with this spice or with that other spice. If you go to a restaurant, first of all, the choices are limited in the menu. And second, your cook at your favorite restaurant will decide the amount of salt, will decide how much pepper, etc., etc.
True.
So in here is the same. Virtual WAN is a concept where Microsoft takes over the management of that centralized hub for you.
Mm-hmm.
You still can deploy firewalls. You still can deploy certain SD-WAN appliances, and doing so will be much easier than if you did it on a customer-managed hub VNet.
I see.
Because Microsoft will give you this portal experience or API or REST API experience or Terraform or whatever with much fewer options. So think of the restaurant menu, right? You will just pick whatever you want, boom, it will happen.
Mm-hmm.
So while it's incredibly easy to configure, the price you're paying there is flexibility. If you decide that you need something that Virtual WAN is not giving to you, it's sort of hard implementing that, because it's as if you want something which is not in the menu in a restaurant, right? It's like you could try to get your way, but chances are that you have to stick to the menu options.
True.
So it's a tough question, because in networking you not always know what your requirements are going to be. However, if you believe that your requirements in terms of network connectivity are fairly standard, in the sense that, hey, I just want any-to-any connectivity, or I want any-to-any connectivity, but with a firewall in between so that I can control, then Virtual WAN is fantastic, because it will give you that any-to-any connectivity out of the box without you having to do anything for that.
I see.
If you have more sophisticated requirements, like, I might want to control routing in a more granular way, or I want to deploy different SD-WAN appliances, for example, here than there, chances are that with Hub&Spoke, or with customer-managed Hub&Spoke, I should say, you are going to have more difficulty in day one, because it's something that you are going to do more or less manually, but you will have more options going forward.
Yeah.
So it very much depends on your operating model, whether you prefer cooking at home or going to the restaurant, and on the requirements of your connectivity model.
Exactly. So you could have an SME with a smart workload where they'd be fine with the restaurant and virtual WAN, but for the other works with bigger and more complex workloads and traffic control requirements, Hub&Spoke would be the option.
Exactly.
Nice. Okay, you probably have a bunch of customers in their migration to Azure to this day, which is why I want you to share some of the biggest networking challenges when going to the cloud.
Yeah, we touched upon some of these, right, at the beginning, like trying to replicate whatever you're doing on-prem in cloud. Sometimes that works, but oftentimes it doesn't. In other words, assuming that the cloud network is going to work like your on-prem network, assuming things in IT doesn't end well normally, as we know, if you've been long enough in this industry. And another one is trying to do things manually. And with doing things manually, I mean using the same processes that you have on-prem. Again, it's similar to technology, but now I'm talking about processes, right? It typically introduces friction, if not additional or unnecessary costs into the cloud. For example, sizing is a very trivial and easy to understand concept, right?
Gotcha.
On-prem, you used to size a server for 3 years. In Azure, you can, or in public cloud in general, you can be much more aggressive and size it so that you are going to fill it 80% from day one. But guess what? You need to have a process to continuously right size that machine. So some processes need to change as well. And maybe to let a third one fall, going back to the networking realm, some things I've seen going wrong in cloud is the same thing I was seeing going wrong on premises in migrations, which is trying to keep the same IP addresses at both sides of a migration. that's always a recipe for trouble. I know many people don't like to hear that. Like, I cannot re-IP my servers. I need to stretch layer 2 between my source and destination data centers. I understand there can be a lot of reasons for doing that.
Yeah.
But be aware that you're heading into a world of pain.
True.
When doing that.
It actually goes both ways, because sometimes it's even hardcore in that application. So the team would tell you, we're not touching anything. You ops are going to keep that same IP. But at the end, you're just going to transfer that pin from a team to another, unfortunately.
Correct. That's, 𝐏𝐨𝐲𝐽𝐼, that's exactly correct. You are just moving complexity around from an application poorly designed or poorly documented to a network that is going to be poorly designed. And performance will suffer. Troubleshooting will be much harder, like an order of magnitude harder. I'm not talking about looking here and there, but it's going to be like hard with capital H. And scalability will suffer with some of those layer 2 extension mechanisms. You are advertising /32s all over the place. So not to mention broadcast storms and what I was saying earlier about layer 2 impairing your scale. Guess what? That's going to impair your scale big time.
Yeah.
But hey, I understand sometimes you can do that. But if you ask me about things getting in the way of migrations, that one is on the top of my list.
I agree. Makes total sense now. Thanks. All right. Let's say I'm a small-sized company CTO going hybrid, right? Could you help figure out where to start, like the do's and don'ts and best practices, and how to keep it optimal and cost-effective without sacrificing availability, for example? I'm speaking about how redundant should it be between IPSEC, express route, and third-party secrets, and so on.
Yeah. So so first of all, it can be different motivations going to cloud, right? One of them could be disaster recovery. I will go for another one, which is, hey, I have this new application and I don't want to buy physical hardware for this one. I want to try this new thing everybody's talking about, which is the cloud.
You bet.
So my advice would be trying things with the right attitude, with the right mindset for the cloud. What we were talking earlier about changing processes and trying to automate stuff, I would try to do that, right? Like picking up an application which is maybe not that critical, so that you can try new things and start introducing this new culture, these new processes and tools to your organization, so that the new cloud culture starts permeating your whole organization. And once you've done that for one application, you can do that for all of them.
Sure.
If you start with very critical applications, let's say SAP, of course you can do that, right? I know a lot of organizations that have started moving their SAP systems to the cloud.
Sure.
But you don't play with SAP.
No. No one does.
So more often than not, those migrations are lift and shift, meaning you just move things around without actually changing them.
True.
So my advice to an organization moving to cloud is starting with something that they can use to learn the cloud principles. And if we are talking about an SMB, a small or medium business with limited resources, that's might be challenging because their IT department is going to be short on resources always.
Totally.
Still, I think a good small IT can leverage a lot of cloud tools so that they can start learning and improving and creating new processes without necessarily increasing the load to an unbearable level. And that's going to work for everybody. Even for those specific admins, it's going to be a significant bump in their curriculums. When they move up from just being local admins to being cloud admins as well. Does that make sense?
Yeah, it makes sense. So would you say that the basic config for a high-bit connection would be like, let's say, start with the VPN, double tunnel, and then later down the road, you can look for express route.
Yeah, probably
if needed.
Exactly. If you follow my chain of thought when I was saying an application that is not so critical, eventually you might not even need VPN, right? If it's an application which is serving users over the public internet, you might just deploy those servers out there in the cloud and connect via a Bastion host or something like that. If they need connectivity back home to the mothership, yeah, maybe a VPN is good enough, and you don't have to pay any costly lease lines or private connectivity. So yeah, I mean, just deploy your Kubernetes cluster or your virtual machines. Try to deploy your application using modern deployment strategies such as cloud init files that you were mentioning earlier, or more modern approaches such as immutable infrastructure with what we call in Azure virtual machine scale sets. But the whole point is find something that works for you as organization, but do not necessarily let yourself be limited by what you are doing today with on-premises. Try to be creative. Go to meetups, talk to other people with more experience in the cloud. Try to understand what's working for them, what's not, and be innovative with that little application you started.
Yes, sir. And try to read those Azure community blogs because they do have cool practical scenarios, not just theory.
Yeah.
Okay. Speaking of which, we used to only hear about either VPN or direct connect or express route. But lately, there's a new trend in town, which is IPSEC tunnel through direct connect. Where do you think this came from, and is it a hype, or is it worth the latency even? What's your take on it?
It's security. It's security. So you might have heard that sentence like dance like nobody's watching and encrypt like everybody is.
What? It's literally the first time I ever heard about it.
So it's that thing, right? If you have a direct or a private connection, what this means is that your bits and bytes are not going to traverse the public internet, but they're certainly going to traverse equipment that doesn't belong to you.
True.
That equipment is belonging, in this case, to your network provider, and then eventually to Microsoft. How much do you trust those physical locations? Because what you're trusting here is that nobody's going to be able to sneak in physically and sniff into your cable.
Yeah.
Obviously, if your applications had native encryption, you wouldn't need anything of this.
Yeah.
Right. So if your application traffic is already encrypted, you wouldn't care people sniffing your traffic because they wouldn't be able to decrypt anything.
Exactly.
Let's forget quantum computing for a while. But if your applications are not natively encrypting traffic and enabling those applications with native encryption is going to be too costly for you, what you could do is you could provide networking encryption, which IPSEC does really well these days. It introduces a bit of latency. It introduces some bandwidth limits.
Okay.
Due to the CPU architecture, where single threads are typically mapped to single cores, so you typically have a bandwidth limit of, say, 1.5 to 2.5 gigabits per second per thread. But if those little latency increases and those bandwidth limits are cool with you, then the overall security bump that you gain could be very interesting from a security perspective, right? And then you're certain that even if somebody broke the physical security of those individuals or those organizations who are actually managing your routers, they will not be able to see your traffic.
Fascinating. Okay, so that's for paranoid, but I want you to save me before I get lost. When we're talking about performance, like 1 gigabits per second per thread, are we talking about the devices or virtual appliance or virtual gateways?
Yeah, we're talking about physical CPU cores. Yeah. So
okay. Yeah.
Virtual appliances.
But they're virtual machines, right? In the cloud. That's what I want to know.
Yeah, CPU cores. Like I was talking about virtual machines, right? Another difference between on-prem and cloud networking is performance. When you have hardware with dedicated ASICs and circuits to provide a networking function, your performance is going to be limited only by those circuits. So you easily can reach really high performance numbers. But in Azure or any public cloud, you typically don't have dedicated ASICs, but you have like standard VMs performing networking functions,
Oh,
or what the industry call virtual network functions, VNFs. So those standard VMs will be riding on Intel or AMD CPUs with that are made out of cores, of CPU cores, right? And the performance of your network will be down to the performance of those CPUs,
interesting.
which are generic purpose, not as your on-prem ASICs, which are specifically built to switch packets or to encrypt packets or to route them.
Oh,
So that's what I was meaning, right? When you have a VPN in Azure, a virtual machine in Azure doing VPN, the performance of those VPNs are going to be limited by the hardware on which that specific virtual machine is running on, and more specifically on the CPU of that hardware.
Interesting. Right, but is there a way to get around the performance limits of these VM-based network appliances? If my traffic suddenly grows, for example, can I scale up or pick up a different SKU for my virtual gateway? Is it possible to get more processing power?
Yeah, you can, like, for example, our VPN gateway, it has different SKUs, and the higher SKUs have more performing CPU cores, which give you a bit more bandwidth per tunnel. Like, I don't remember the numbers, but I think the lower SKUs give you like 1.25 gig per second, and the higher SKUs give you 2.4, so it's almost double. We are working on, as well in technologies that will improve that throughput even more by offloading some networking functions to dedicated hardware.
I see.
Which we already do partially, where with FPGAs, with field programmable gate arrays, which is kind of something in between software and hardware. It's programmable ASICs, oversimplifying quite a bit, which is connected to our virtualization host and can perform some networking functions without incurring in that performance tax that software networking has. So we are working in extending that, right?
Interesting.
But today, yeah, you are restricted to moving along SKUs of your VPN gateways in Azure, or you could try to go to virtual network appliances that do not suffer from this limitation. For example, I understand some Cisco appliances don't have this limit. Aviatrix appliances have this insane mode or high performance mode of VPN in which they can spray traffic over multiple cores. So yeah, there are some techniques and options to go around those limits. Bottom line is you need to be aware of those, right? And whenever, as we were talking earlier, wherever you take a design decision, it's going to be a trade-off between certain things. For example, you go to a higher SKU, the obvious trade-off is going to be cost.
Of course. Absolutely. Okay. This one's my favorite because you're a very prolific contributor in the field. But for those who don't know, tell us some of your most helpful Azure community contributions in GitHub. This is literally how we discovered you, by the way, but tell us more.
Yeah. So I've been quite a long time in the industry, so I have bad memory. I try to write down what I do so that I don't forget. My blog is in cloudtrooper.net.
Cool name.
I've blogged about different topics. The most read ones, or the ones that have got most attention, are the ones around Azure Route Server.
Okay.
Which is a service that we brought to the market around 2 years ago, which enable appliances to inject routes into the native Azure SDN routing with BGP.
Nice.
It's very flexible and hence allows a lot of things. So we've had a lot of customers trying interesting stuff, and I've had the opportunity and the privilege of testing those designs and trying to see what works, what doesn't work. So I've been blogging a bit about those. Those were very well taken.
Cool.
The other type of blogs that has got the most positive remarks has been some I wrote 4 or 5 years ago about Kubernetes networking, specifically in Azure with the native Azure Kubernetes service, which is called originally Azure Kubernetes Service, AKS.
Of course.
And there I went in the at depth and at how different networking constructs in Kubernetes are implemented with IP tables at the time.
Wow.
And the load balancer, interactions between public IPs and Kubernetes constructs such as services and network policies. So yeah, I would say those two. Other than that, I have some labs that are well attended. I have training on Kubernetes as well in something we call the What the Hack. It's in GitHub as well.
Okay.
If you want to read more about those, the URL is aka.ms/WTH for What the Hack.
Sure.
I wrote a couple of those in networking and Kubernetes.
Oh yeah.
Again, pretty well received. And yeah, I would say those are the highlights.
Nice. Awesome. I'll make sure to put them in the show notes, and I'll definitely check out the Kubernetes related content. Didn't even know you had them actually. What the heck? And of course, for me, my favorite is the Azure NVS repo in your GitHub about those license-free CSR appliance labs that we talked about earlier. Super handy.
Yeah, so happy they're helpful, Jose.
Absolutely, Jose. Quality content and very useful as always.
Excellent.
Okay, this was another epic episode about networking with Jose Moreno and not Moreno the coach. But guess what? You think we're done with networking? Nah, we're just warming up. This is why we, ladies and gents, are cooking up part 2, parte 2, coming up soon. So don't go nowhere. This is Tech Bits Unplugged. I'm your host, Cloud Dude. And until then, don't forget to share the word, tell a friend, hit subscribe. Catch y'all soon. Peace.